Hi, my name is Ethan, and this is my video project. In this presentation, I'll be going through the structure that I selected, its calculations and results, and finally some of my opinions on the calculations used for the analysis of my structure. The structure that I chose is a picnic shed located in a neighborhood park at my old address in Blackburn. I chose the structure due to its straightforward construction and indeterminate nature, as well as me being able to easily access the location for surveys and measurements. Its simplistic structure was also part of my decision because I wished to find a structure that was suitable for me to apply all the analysis methods without digging myself a hole by choosing a overly complicated structure. The first comparison is between my calculations of the reaction forces using the force method and approximate analysis method. I started the force method by modifying the support conditions so that the degree of indeterminacy is 1, and thus making it possible to separate the forces for the primary structure and the redundant structure. I then identified the compatibility equation and calculated the reaction forces of the primary structure using the equilibrium equations. And next I constructed my moment equations for the primary structure using the load conditions I got from my student number, as well as the moment equations for the redundant structure using the virtual load of 1 kilonewton. After obtaining all of the moment equations, I applied them to the compatibility equation in order to solve for the horizontal displacement at point A, as well as the linear flexibility coefficient, and after which the real horizontal reaction force at A was gained. And on the other hand, I applied the concept of approximate analysis to my structure with the same loading conditions. I separated the vertical and horizontal loads into part A and B respectively, and solved them using the frame and portal method. So comparing the results from the two methods with the same software check, it is interesting to see that the force method has a higher accuracy for vertical reactions, whereas the approximate analysis method shows a greater accuracy for horizontal reactions. Next is the comparison between the calculations from my slope deflection method and moment distribution method. For both methods, only the vertical load was considered, and the supporting conditions stayed the same. For the slope deflection method, the fixed end moments are first calculated, and in this case, because of the two pin supports, member AB and member CD have FEMs of 0, and FEM for member BC was calculated normally. After which, the slope deflection equation was applied to each member joint, and the deflection angles for joint B and C was solved using equilibrium equations. The deflection angle value at B and C are then substituted into the relevant moment equations, from which we can obtain the internal moment reactions at the relevant joints. And for the moment distribution method, the carryover factor, stiffness factor, and distribution factor are calculated for each respective member, and the same fixed end moments are used. Using this information, we are able to set up a moment distribution table, and after several cycles of solving, we are able to get a relatively accurate answer. It is worth noting that when comparing the two methods, the results obtained from the moment distribution method is significantly higher than the opposing method. I speculate that this could be a result from heavier involvement of the moment of inertia in the moment distribution method, as the moment of inertia for the beam is significantly smaller than that of the columns, and in the slope deflection method, the moment of inertia is not a crucial factor and are often cancelled out in the equations. From comparing the shear force diagram and bending moment diagram from part 2 and part 3 of the project, we can see the same interesting results where the vertical reactions for shear force in part 2 is more accurate than that of part 3. However, the horizontal shear force in part 3 bears a close resemblance to the software check. And it is also interesting to note that the bending moment diagram in part 3 is in general more accurate than part 2. This could suggest that the moment distribution method is a more reliable method than the slope deflection method. But it also could just be my personal preference when it comes to calculating for the moment reactions, and therefore ending up with better results. In general, I think this project serves as a great opportunity to practice different structural analysis methods, from which I can gain a better understanding on the unique approaches of each method and in what way they appear to excel at. In my personal preference, I think the approximate analysis method and moment distribution method are better suited for a real-life professional setting, as an engineer's time is often limited and client demands are urgent. Although we can occasionally get better results from the other two methods, in my view, they are overly complicated, time-consuming, and harder to explain to clients. And those are some major disadvantages, especially in an industry where decision-making efficiency and communicative ability are priorities with clients, and the details are often allowed to be worked out behind the scenes. And this has been my video project. Thank you.